Hi, everyone. So we're going to start this webinar, the webinar series of life cycle assessment and reporting for buildings. I've got a chance today to welcome Dr. Martin Rock, Executive Director at RISE Labs, and also Dr. Zuhaib Batra, Scientific Collaborator at the Smart Living Lab in Fribourg. So on my side, I will host this meeting. I'm Professor Thomas Jusselm, full professor at the Energy Institute in the University of Applied Science of Western Switzerland. So today, the webinar outline will start with a 5-minute welcome of myself. Then we had the chance to hear Zuhaib with the first session about life cycle assessment reporting frameworks and standards of 15 minutes. And the second session of Martin will be about insights to actions, a global building data framework to advance climate policy. Then we will have the chance to have a 20 minutes question and answer. And then we will be able to close the session. As a short introduction, I would like to introduce our institution. So we are part of the University of Applied Science of Western Switzerland, and more specifically, we are the School of Engineering and Architecture of Fribourg. We have 10 research institutes, and we are part of the Energy Institute in between industrial technologies and construction and environment. At the Energy Institute, we also focus on the applied research in energy systems. On my side, I have a contribution at the building scale and more specifically about life cycle assessment of buildings, carbon budget of buildings, early design methods, including the life cycle assessment and environmental impacts. We are part of a couple of research projects, like, for instance, the bio projects that were focusing on bio-based material and their contribution into the biogenic carbon storage effects at the building, but also the building stock scale. And if you want to know more about our research and publications, I can only invite you to go on the website called www.buildinglowcarbon.com, where you will see our publications, but also our projects and the outputs and deliverables of the different projects. So we are here today because, as we all know, we need to meet climate goals. And the building environment is responsible for 40% of the climate change, and more specifically 10% for the building materials themselves, with what we call the gray energy or the embedded emissions. And we are in a really specific sector with a large lifespan of buildings where the inertia to change buildings and to decarbonize this building sector is really challenging, with a very long and complex value chain. And we feel and believe that there is a lack of awareness about the latest research outputs. And also we need to support policymakers and to fill policy gaps. So this is why we decided to start this webinar series by sharing our latest research findings, but also by inviting key researchers in that space. This is why we have Martin with us today. So we also know that we have a kind of momentum at the European scale because we have the EPBD that will come into force in 2028 with buildings that are more than 1,000 square meters, with regulation that will be transposed in all the EU state members in 2026. In Switzerland, we have the chance now to have a norm, the LCA 390, that determine carbon thresholds for buildings. And we have progressive and new regulations in different European countries, starting from France, that have massively regulated this space in 2022. We also have an International Energy Agency task, the Annex 89, that we are part with Zuhaib. discussing about ways to implement net zero whole life carbon buildings and delivering very key reports in that space. So again, happy to have all of you today. Just a couple of instructions for you attendees. Feel free to ask any questions during the session in the chat box. Don't forget to mention the name of the speakers, so at the end, when I will moderate the Q&A, I will understand who was to whom was directed the question. You can also use QR codes to connect with the speakers on LinkedIn. Your mics will be disabled, so really, if you would like to ask a question, you have to go through the chat, and the camera will also be disabled during the whole session. I will be also the moderator and the timekeeper, so Zuhaib and Martin, I will take care of the 15 minutes, so please try to be on time. I've got a chance to give the floor to Zuhaib for the first session. If you would like to take the lead on the presentation, welcome Zuhaib, and thank you for your contribution.
Thank you very much, Thomas, and thank you everyone who is joining in. I'm glad to present on the topic of LCA reporting frameworks and standards. It is very important for us to reflect on the growing momentum that was highlighted by Thomas in his slides. The story of carbon emission is locked in its materials, and it's often buried in a 50-page report. And we really don't know who has access to it. Can we compare them, or what can we learn from these LCA reports, which are generated at building level? And there's a core challenge today is moving from these isolated reports to a more dynamic and data-driven system. And it is a time that we should really look at benchmarking them and making real-time decision-making using this rich data that we have on LCA. As we know that building LCA data reporting in Europe is the need of the hour, and in the coming time, the regulatory requirements are going to be more strict. So it's better to brace and prepare for that in advance and learn from what we have done in the past, such as development of energy performance certificates and related databases, reporting of energy performance certification schemes. So there have been so much that we have already done in the past. It's time to learn from it. And one of the main instruments that is already out there is the Energy Performance Building Directive in Europe, which is asking us to do whole life carbon disclosure in EPCs, specifically from 2028 for buildings with a greater than 1,000 meters square, and also for all new buildings from 2030 onwards. So it's going to become something mandatory, and it's not very far from the time we are in. Member states are also required to produce their national roadmaps by setting the global warming potential limit values by 2027. So it is all the more important for us to collect different kinds of data that we have on different building typologies in Europe and start understanding the challenges that we are going through. So today's discussion or presentation will be more about understanding these challenges and how in our research we are trying to overcome that. We know that there is a delegated act, and collection of national data under EPBD will become mandatory in the coming time. There will be emergence of new databases and use of standard documents to exchange this information. So we are already leading this task and trying to understand the core challenges and work towards them. There is also levels framework at the European level, and it is something that is providing us initial guidance, but still not very detailed and very much enriched. So I think these are just the stepping points of movement that we are going to get into over the coming years. Just giving you an overview of the landscape, what's happening. We know that Europe is at the forefront of reporting and developing whole life carbon assessments. And it's not the case yet. We see developments also in other parts of the world, whether it's in North America, whether it's Canada or Australia. But we also see that the leaders are here in Europe, and there's no doubt Denmark, France are one of the leading countries who are working on reporting whole life carbon assessment data. We know there are countries like Germany who have already some reporting that is required and mandatory at the national level for public buildings, whereas other countries like Sweden, Finland, and Norway are working towards developing more detailed systems. We also know that there are leading voluntary certification schemes in many of these countries who are also leading the task of developing LCA-related data collection and reporting systems. So this is just an overview to give you an idea, whereas Switzerland also is not far behind. We do have standards that have been set up at national level, but their enforcement is still lacking, and the government is still working on making them mandatory at the national level. Just to give you an overview what exists in terms of databases, there is some really excellent work out there from different organizations who are consolidating whole life carbon building data. And it's very interesting to see that these initiatives are making more and more clear understanding of how LCA data is collected, or they're trying to show us the hotspots in which stages of building life cycle really there is a lot of stress on improvement. So we see there are many examples such as the French RE 2020 Observatory, which is one of the national observatories available for people to check in. But it's still, there are some challenges in these observatories where we find that the granularity is missing. We don't find material level information, and sometimes it's challenging for someone to analyze them. These are some excellent examples from BECD or SWECO from Denmark, Compare from Ramboll, and one of the initiatives by GBDI, which will be elaborated by Martin in his presentation. We understand that there are some core challenges, and let's try to break them down. The main issues are data silos and fragmentation. Each country's database is very, very different, and there are different calculation methods at national level on whole life carbon assessment. We know there's a Dutch method versus there's the French method, and they're all different based on the climatic conditions. This causes the results to be really inconsistent. And what is happening is that there are different tools, they give different results because the underlying assumptions are very different. Second most important issue that we are facing right now in looking into LCA data is the common schema or reporting schema where a shared language is there for building LCA. We have a very good example of BIM where IFC formats have been used from more than a decade now, and it's used as a very common language in exchanging information between building information modeling users. Similarly, we are missing something like this at the global level, or I would say even at the European level. And this is one of the challenges, and there is this complexity around that, and we have to solve this complexity by research. We need data not only for submission, but also it should be structured, verifiable, and trustworthy. We are having challenges in structuring LCA data because there are several types of different practices at national level. Some people are working only at very coarse level, some are going into very much detail, some are reporting it in their national classification systems, whether it's architects, engineers. So there's a lot of, I would say, disaggregation into how things are reported, how they're understood, and often the quality of information is not very reliable. We find that the workflow from BIM design to LCA is still prone to error. There have been some really great efforts to transform IFC related files into BIM, into LCA related files. And there have been some tests, and this is a direction where we think we should be moving forward, trying to use existing technologies, but also developing LCA reporting formats which are more aligned with national or international industry standards. So imagine that if a building authority effectively wants to verify thousands of PDF reports of LCA, it's a very big compliance issue. It will be very difficult for public authorities to really understand what's going on. So it is in the benefit of all the stakeholders who we are going to work with in the future and have digital interoperability between different systems that we have at national level. And utilizing the existing standards would be one great way to move forward. Here I would like to share a status quo about building LCA reporting in some of the European countries. This is very interesting to notice, as you know that there are several tools. Different countries in Europe have developed tools which can be used at national level. There are compliant softwares which can be used, and there are some lifecycle inventories which are already established and very much advanced in some countries. The reporting stages are very different in different countries. Sometimes it's the reporting of LCA is required at the as-built stage, and sometimes it's at the building permit stage. Different formats are being used, and some of the examples are using Excel format, JSON, or CSVs. So there is a lot of variation at different countries level, and then we have to understand that this variation is not very conducive to sharing and exchanging data. That is why we need to overcome these challenges. There is definitely one issue, that is the fragmented reporting that I highlighted. And France is a clear leader in digital standardization. I would like to cite their example of RE 2020 regulation, which mandates the use of an XML file for reporting the LCA at building level. It's a machine-readable format, and it can be used at the national level to report the results. Other countries definitely include Denmark, Germany, Sweden, who are paving way for machine-readable formats as well. So fragmentation is a biggest bottleneck in data sharing, and we're trying to overcome this issue. And imagine trying to build a financial model by manually reading thousands of PDF bank statements, and it's inefficient and unscalable. I think that's one of the issues similarly we are facing in the LCA world. So we need data which is more easily understood and reported. For this, we have been working on one of the very, very exciting projects, BLAREC, in our institution. We are trying to develop an LCA assessment and exchange platform. It's a Swiss carbon performance framework where we are trying to overcome the issue of common data exchange format, which is human readable, as well as build a Swiss level repository with this data. Now, there is an approach that we are following. I would like to share that with you very briefly on the screen. In this, we are working with several LCA data, which we have collected from industry partners, and we are developing a .lc Python package, which includes a JSON schema. And also, we are applying the large language models to really extract the data from what we have received from industry partners. We have included stakeholder feedback to understand how this schema should be arranged, and also develop a JSON, which is known as .lca for data exchange and reporting. Finally, using these JSONs, we will transform the data that we have into a prototype data repository. And definitely, and as an outcome, we'll have a format which is tested on the data that we have received in this project. Building LCA data exchange is really important because there is a series of exchange that is happening between different stakeholders, as we know, between engineers, real estate developers, investors, or even public authorities for their decision making. LCA data is the center point of a lot of stakeholders in decision making. I think we need to really step up, understand our research course where we are working, and try to focus on these exchanges and try to develop solutions which are not holistic in one way, but also try to focus on the issues that each of these stakeholders are facing. So we need to understand the value chain very clearly. I would like to share some examples of a survey that we conducted and is still ongoing. So these are some preliminary results. And we asked different building professionals about the formats that they are using to exchange LCA data. It was very surprising to see, of course, no doubt, Excel files dominate the landscape, and PDF reports are second to none. So it is very, very challenging that these two formats are, as you know, are not really machine readable. It is very difficult to use them. They can be huge files and heavy files. Imagine tens and thousands of data that is existing in these kinds of formats. So we need to really solve this issue and have something which is easily interchangeable and interoperable. We also asked some of the respondents about the common issues that they're facing while exchanging the data. One of the issues is, of course, the lack of clarity on assumptions and system boundaries. And we understand that in LCA, we have a lot of assumptions that are taking place, and these are often not reported in the reports that we have been submitting to building LCAs. So it is very important to overcome this issue, missing incomplete data. Often there is not a lot of data which is required at granular level to understand LCAs. So this is something that we observed. And finally, one of the results is about the challenging and accessing or using LCA data is about data availability and standardization and quality. No doubt, these are some of the very, very pressing issues, and our projects are really motivated to learn from these learnings and also move forward in developing the right solutions. I would also like to highlight one of the things that is important in reporting is the minimum dataset composition. When we are reporting our building LCAs, it is very important for us to highlight the things that we really need to report that could be used by different stakeholders. And in our understanding, building metadata should include information like project IDs, typologies, the units that have been used. There should be sections about administrative data, information about the stakeholders, the scope that is included in the LCAs, and a very descriptive section of results where the module by module description is also available of all the results. We also need to highlight certain scenarios based on different service lives, energy mixes, and of course, the versions of data sets that we are using. Every now and then databases are changing very, very frequently. So we need to highlight what versions we are working with, especially with unique identifiers so that it is easy to track which database was an LCA prepared or shared or conducted. So we have identified these requirements and we have started to work on building a schema in JSON. Also, one of the important things that we come across is building element classifications. This is one of the foundations of building LCAs. We know in different countries, there are different ways to create a bill of materials or bill of quantities. And this is the material level information, often classified as structural work or foundation work or painting work. There can be several categories in which it is identified. But what we need to know is that across the world, there are so many and different kind of systems that are existing, which makes it practically impossible to translate one form of information from one country to another. That is why these classification systems holds a very important role in our understanding how data is exchanged within the value chain. In our analysis, we have analyzed uniclass, or I would say co-class ECCC batch systems, which are very, very widely used and often very, very comprehensive in reporting different products and materials and processes under pre-specified categories. This makes things a little bit easier to understand and classify materials in LCAs and also share them across the value chain. So this is something that we are analyzing in our work, and our structure of LC data reporting and exchange will definitely be influenced by these building element classifications, which may be in future possible to exchange from one country to another, but that is a long way to go. Finally, to wrap up, we know that building LCA is here to stay in the next decade. Our current reporting infrastructure is really not fit for purpose. So by focusing on open standards, mandating machine-readable formats, and maybe fostering an ecosystem of connected tools is what we need to use to really unlock the potential. We need to really develop open standard schema, something like based on XML or JSON to really share building level LCA results. What is also not yet in picture is mandating in policy how these machine readable formats should be used. Maybe EBPD could consider it as a recommendation and start influencing the policymakers on using a specific format for exchanging this data. So I believe we have several paths on encouraging even software developers to work with open APIs and try to exchange data in formats which are easily accessible and available. There is already some good practices in Denmark or in France in this direction. I think we need to learn from them. We need to use some specific data converters, which is very easily available and also connected to national portals who can use this information or exchange with some interoperability. So with this, I think I would like to bring your attention to the challenges that you are facing, and please be a part of our latest research. You can scan this QR code to access a survey that we are already conducting. We would like to hear from you what challenges are you facing so that we can include specific directions in our research. With that, I thank you for listening.
Thank you so much, Zohaib. You were just on time and very well presented, very interesting. And now I have the chance to leave the floor to Martin. Martin, if you can take the lead on the presentation, then you can move on for your next slides. Thank you so much.
Yes, thank you so much. I believe you now see my title slide.
Good. Yes, that's perfect. Yes. And
perfect.
Take the chance to have the mic. Just if you want to leave questions, don't forget to write the questions. I've seen you started. That's great. Thank you so much.
Perfect. So thank you so much, Thomas, and also thank you, Zohaib, for the invitation to this webinar. It's my pleasure today to speak to you about our work and insights, or our work on taking insights to action and our work on global building data frameworks to advance climate policy. I will really give an overview of the breadth of the work that we're engaged in, and I'm looking forward and also to questions and discussion at the end of it. So I will be brief on those because you already understand the context. The built environment is very relevant. We know it's around 40% of emissions, of CO2 emissions globally. We also know that, especially for new buildings, the embodied material-related emissions are of increasing importance. Our research shows that it's 50 up to 90% of life cycle emissions for new buildings are actually related to the material production, the material processing. And within those embodied emissions, we see that around 2/3 are often linked to the structure. Depends on the complexity of the building system, but it's often the structure really plays a key role. And now I realize that animations will not work well in this setting. Anyway, we will skip over this. The important thing to understand about emissions is that there is difference between the operational emissions, which are the orange part here. They occur year on year throughout a building life cycle, and they are more or less even. They are affected by overall decarbonization of the energy system. They are affected by interventions on the building that might improve the energy efficiency, replacements, maintenance, or small renovation cycles. On the other hand, we have the embodied carbon emissions, the blue bits, and those are really occurring in spikes. So we have pulses of emissions that occur for the initial sourcing and production of construction materials. And this is this big bar on the very left. And this really is a lot more than the first few years, actually the first few decades of a building in operation. So we see this upfront embodied carbon spike, as we call it, which really dominates 20, 30 years and more of the life cycle emissions of new buildings. And that's really also part of the reason why we call for action on embodied and whole life carbon emissions, especially for new construction today. Because the thing is, we know that there are many solutions already available to reduce, especially those embodied carbon emissions. Great progress has been made already on operational carbon, but on embodied carbon, there are also great solutions available. We could reduce embodied emissions by 50 to 75% with the strategies that we have today. And you can see here an example of the decarbonization of the key materials, steel and concrete, where we consider still a demand growth from a global perspective, but there are different options. You can have a substitution to timber that will get you some emission reduction, but it's actually very limited when we look at it globally. But you can do a lot also in better design and material efficiency, choosing better and low carbon construction materials. So really this combination of the strategies of avoiding, shifting and improving material use has a lot of potential. The problem, as Suhaib already said, is that we currently don't really have performance requirements on these embodied carbon emissions in most parts of the world. And that is why also my work and our work has focused on really adjusting the rules towards net zero whole life carbon buildings and making sure that we inform policy in a way that increasingly incorporates these embodied carbon emissions in the regulation. Suhaib already spoke briefly on the European perspective. This is also zooming in on Europe, the EPBD, the Energy Performance of Buildings Directive. We now have a timeline really laid out where European frameworks for the calculation of global warming potential, so of whole life carbon emissions for buildings, are being prepared. And there are also national roadmaps that will spell out targets and limit values over time. And from 2028 onwards, we will actually see the mandatory disclosure of greenhouse gas emissions of new buildings, of large new buildings, larger than 1,000 square meter. And from 2030 onwards, we will see a disclosure requirement for all new buildings, including not just disclosing the global warming potential results, but also showing that they comply with the limit values, which will be set out in the national roadmaps. So that is a very interesting and very exciting perspective, because we believe it's a critical step to really reduce emissions from buildings with a life cycle perspective. And it also shows that now is the critical time, the critical years to prepare for this and also to shape what whole building and whole life cycle reporting will look like in the future. Part of our work in accelerating the uptake of these forthcoming regulations and also informing these requirements is the Indicate framework, which is a framework for accelerating whole life carbon data and policy creation. And those of you who are interested, you can look it up, indicatedata.com. It's a framework that we have now already, or that we are deploying in the second phase. We have worked with 3 pilot countries, Ireland, Czechia, and Spain in the first pilot. Now in the current pilot funded under the European LIFE program, we're working with partners in Italy, Croatia, Austria, Hungary, and Luxembourg to really support them on this duality of developing the data and the assessment methods on the one hand, while also developing really specific whole life carbon policy proposals and working with stakeholders, also with policymakers towards policies and the implementation of these European trajectories at the national level. Now, what we're also doing in parallel, not just on the individual building level, but we're also working at the building stock level, because for policymakers, it's quite relevant to understand, yes, on one hand, what can be done on the individual building level, but often that is quite different from what can be done at scale at the national or the European building stock. So part of our work is really taking these building level results. You can see them here on the right, the hierarchical models of buildings where we really have the materials in the elements to really be able to show which are the hotspots in terms of materials and life cycle stages. What is the carbon profile of an individual building? But we're taking that data and scaling it up to building stock to model what are the emissions, what is also the material demand, the material flows related to the new construction activity, to the demolition activity, to the buildings that are in operation and might be maintained or undergoing replacement activity. So we model all of this at the national and transnational scale to really then investigate the evolution over time and the potential of different low carbon solutions to really reduce emissions or maybe even activate carbon removers at the European and at the member state level. The way that we go about this is by modeling archetypes. So we build on statistical analysis of the construction activity, of the composition of the European building stock. And in this project that I'm pointing to here, you can again find it online. It's for the European Commission DG GROW, a preparatory action on the life cycle emissions and removal potentials of European construction. For this project, we really modeled archetypes for all the 27 member states, considering different construction periods, 11 periods, 9 different building typologies, also going into the nuances of geometry, of structure and materials, of different energy performance and energy systems to really model comprehensive life cycle inventories and then conduct whole life carbon assessments and LCAs. Now, the final reports of this project are already delivered, and there are a number of publications that will be coming forward. So this is just to give you an idea and keep you excited about what's coming, because there are around 10,000 building LCAs that we modeled and that we plan to publish to a large degree in the coming months, so that you can also look into these numbers and understand the contribution of different materials, the contribution of different building elements, really benchmark this data for different building types across different member states. We also have a specific analysis on the carbon uptake potential, and so in that sense, the carbon removal potential of different types of buildings, considering both biogenic removals as well as mineral carbonation and mineral removals. I think that is also giving quite an interesting insight into the potential and also the limitations of these different approaches. And as I said, we went also from the individual building level to the building stock level. So what you're seeing here are some of the key results, one of the scenarios that we modeled for the European Commission on the trajectory for whole life carbon emissions of the European buildings and how they need to be reduced to align with current European policy and climate targets. And you can see very clearly here on the left, the green part, which are the operational emissions. Obviously, they are quite substantial at the moment. They are around 80% or 75% of the life cycle emissions are operational emissions at the moment. And that is to say, still more than 20% at the moment are embodied emissions. And over time, obviously, the existing building stock needs to further decarbonize. We need to decarbonize space heating. We need to undergo massive renovations and really also scale up renovation activity in order to reduce this green part that you see on the left. And at the bottom, you see the embodied emissions. On the right side, we zoom into these embodied emissions, and that reveals a very interesting reality that we have to face. And many of you might have heard already about the renovation wave and the ambition to implement a renovation wave across Europe. And that's what it will look like. The yellow part here are the yellow part in those bar charts are the refurbishment related embodied carbon emissions. And here you can see from a small share in 2020, this yellow part will have to increase because we want to ramp up refurbishment activity. We want to not just double it, but actually triple and quadruple renovation activity in Europe to meet the decarbonization targets. And that will mean that there is an intermediate spike in embodied carbon emissions from those renovations. And that is a good thing. So that's important to understand. These are really good investments. So embodied carbon is being invested in order to reduce operational carbon emissions. So this operational carbon reduction is only possible if we make the investment in embodied emissions for these increasing renovation rates. Now, these results for this particular scenario, as well as for other scenarios, are available online. I invite you all to have a look at the Whole Life Carbon Scenario Explorer. We have a dedicated website that will point you to an interactive dashboard where you can explore different scenarios, play around with different strategies, activate them to a higher or lower degree, and then really explore the results in your own time. You can filter them for individual member states or for individual building parts, look at different materials, different life cycle stages. All of this. And this is available also through the QR code. We also have a paper pending. The code for this is open source. So if you're working on something similar, you can build on it. Feel free to get in touch if you want to learn more about our experience in also developing this tool, which is really intended to support policymakers. Now, I'm moving away from Europe because the reality is that the global floor area is expected to double, yes, but it's expected to double not in Europe and not in Northern America, but actually it's expected to double in other places. It's expected to increase a lot in places like India. It's expected to increase dramatically across the different parts of Africa. And that is part of the reason why also our work in recent years has moved increasingly to the global level and increasingly moved to partnerships with Global South actors. Because the new construction will really mostly happen in the Global South. And you can see here a historical chart of cement production, which is a very interesting proxy of overall construction activity because it's the main material that is used in the construction sector. And you can see actually for the Global North, there was not much change, and there isn't a projection of not much change of concrete use. But the real change was in China over the last few decades, which really ramped up its concrete production because they had to produce all this basic infrastructure. Now China is declining. Even their own projections see a substantial decline, reduction by 2/3, which is good because they can shut down the ineffective plants and keep the more efficient plants running. But Africa, Southeast Asia, India, those are the places where we will see more construction. And it's also important to understand this construction actually serves a purpose. It serves the well-being and the safe and just future of people in those regions. So in that sense, it's very different also from the perspective that we have in Europe and the Global North more broadly. Now, still to work with partners globally and in the Global South specifically, we have developed the Global Building Data Initiative that was already mentioned briefly. As part of the Global Building Data Initiative, we have developed a data model, the Open Building Data format, and we've developed the Open Building Data platform, which allows, which is a free open access and also open source platform that enables you to benchmark existing data. So here we upload all the data that we can gather from around the world and really make that accessible to engineers, to architects, and to policymakers. And again, that's an invitation to have a look at that. The Open Building Data format really emphasizes this very detailed reporting of material inventories. So we really look for data where we can get the detailed quantities and also the detailed specifications of materials, because we believe this level of transparency is crucial for understanding the data and also understanding where the differences are in the different buildings and not just have aggregated numbers of emissions at the end of the day. The next step, and with this I'm already concluding, is to again take this work at the global level from individual buildings to global building stocks. And there we are starting or have started to work on global whole life carbon monitors and trackers to combine satellite data with the databases that GBDI is managing to really get a sense of where are the material footprints at the moment, what is the whole life carbon emissions, and again work towards scenario analysis at this global level. And yeah, actually I can click it. Okay. So I think the key takeaways for you are that solutions are readily available to reduce whole life carbon and embodied carbon at scale. This is true in Europe. This is also true in other parts of the world. For Europe, more and more holistic effort is required. We need higher renovation rates and depths. We need to decarbonize space heating and hot water production. Low carbon material production, obviously that's already set and many policies are pointing in that direction. I think where we need to improve is actual circular and cascading material use today. So that is not just about preparing buildings for reuse or for disassembly in the future, but it's about using reused materials today and obviously maximizing the use of the existing building stock. In that sense, efficiency strategies are very interesting, especially as they can be very effective today, more today than in a decarbonized future. And it's always important to consider this distinction of global north and global south, where in the global north, it's really about reducing the new construction activity to free up resources for the massive renovation effort that we have ahead of us. While in the global south, it's about partnering with local actors to enable low carbon and climate resilient buildings to really support well-being on the ground. Thank you very much.
Thank you so much, Martin. Perfect timing also, very interesting. And now we're going to switch to the question and answers. So again, feel free to ask any question you want into the chat. We've got a lot of notification of AI note takers. But maybe a first comment coming from Thomas Fedrizzi. That's true that during the introduction of Zuhaib, we did not mention the fact that there will be a new MOPEC or MOOCN 2025 under revision that will lead to have a new carbon threshold, embedded carbon threshold in all the cantons. That should happen in Switzerland in 2029, if I remember well about this revision. Now we have a question, I think, for Zuhaib. What do you think about performance-based functional units like thermal conductivity, durability, mechanical strength? What can you say about this?
Thank you for the question. It's really interesting and a very, very important one, which is, I would say, very popular among professionals who are working with mass-based metrics. So in LCA, we have a lot of focus on mass-based metrics. And to really enable fair comparison between materials, considering performance-based metrics is also very important. As you know, that one material is known for what purpose it is good at, but for what also it is. So keeping the environmental criteria into picture, I think there's a need of databases which can basically highlight the differences between different material types that are being used based on their performance criteria and also based on their mass, basically the environmental impact. So I think it is important to consider this also in the policy making, because this is going to become a very emerging issue in practice, as a product which is highly efficient may not be really good at environmental performance, and a product which is really very good in environmental performance might not have a very high efficiency. So I think it is an ongoing research area and very relevant for the work that we are doing. But this particular aspect needs to be considered in LCA data analysis and also for designers, because when they are making choices about efficiency, they tend to overlook sometimes the environmental performance. So I think it is about creating a balance between the two and informing the designers before they take decisions on selecting a material.
Thank you, Zuhaib. We also have been notified that the QR code provided for the survey have been deactivated. So thank you, Zuhaib, for sharing the link to the survey. If you have time, you can click on the Lime survey and help us to better understand the challenges you're facing when it comes about making life cycle assessments. Now we have comments. To develop material intensity factors, is there agreed upon standards guidance on material density ranges means by material type of EU countries that can be used for converting material volumes at individual building case studies early in the design stage, where you might have EPDs at the building stock level? I guess this one is for Martin. I don't know if it was clear enough or if you want to read it again.
Yeah, thank you. I just read it also, and I think it's a good question. I think it points to the kind of set of open questions that many practitioners have when they do LCA or when they get started with LCAs, because clearly there is information out there on material densities, and you can get a sense of the ranges. But I think the question is pointing to the fact that there is no one source that would be recommended as the source for material densities. And that's true, that's not really there. I mean, obviously, all people who are working with building it, or all tool developers, I may say, will have their own databases of materials and related densities and so on. But I don't think there is this one standard or guidance on the material density of different materials. And I think that would be a valuable gap to close. It's something that we may look into as part of the indicate work also, because there we also look into providing default values for certain building parts that you may not be able to model. But I think, again, maybe that's also an effort to harmonize across the different tool developers, because ideally we make the same assumptions on these things, densities and materials that are missing.
Thank you. We have a call for collaboration from Phong from Vietnam, looking for partners. So if you want to have a look and to get in touch with him or her, would be great. We have a question of Robin. Thanks for the presentation. Can you already give some more information about the cascading use of biogenic carbon modeling? I guess it's also for you, Martin, but maybe so you can also contribute.
Yeah. So
Martin first. Sorry, I wasn't clear.
Okay. So yes. So like our work is not so much actually on modeling biogenic carbon in cascading use so much. There is quite interesting research out there already showing like the obvious benefit of not just taking your timber once, but actually cascading it and keeping it in the cycle for as long as possible, because only then we really activate the long-term carbon storage that we're looking for. Because as long as we use timber only for like 20 or 30 years, even shorter than a tree takes to regrow, we don't really have an effective carbon storage effect of this kind of timber use. So what we want to do is we want to use as much timber as possible. So we want to actually, it's a complicated issue. Actually, we want to make sure that we have sustainable forestry. Then for the timber that we can extract sustainably, we want to make sure that as much as possible of it goes to construction or other kind of large diameter use cases, so that it can be used in a big sense first and then kind of trickle down into multiple life cycles, or then at some point become smaller pieces of furniture, of OSB strand boards, of paper at some point. But I think what we really need to stop doing is using virgin wood for paper. I think that's really a waste of resource. And I think there are very interesting cases also to model this. But that's not really the priority in our own work. I think the case is clear, and also the policymakers are quite aware that needs to be something that they need to consider in frameworks like the carbon removal certification framework. It's obviously a topic also, how do you consider cascading material use?
Thank you, Martin. Suhaib, do you want to add anything on the top of Martin's explanations?
Yes, thank you, Thomas. Just very briefly, I would like to comment on it. Basically, it's not my expertise area, but I would suggest that it definitely keeps the carbon locked away for a long period if we are able to do the cascading assessments. And of course, I think it is very important that it improves the LCA accuracy in general. I would say things are not underestimated or even double counted just because we are able to include them in our calculation. So I believe it's a very useful method, and I think very important to be considered in biogenic carbon modeling, where we have very pressing questions about how it should be modeled, what should be considered, whether use a dynamic LCA or not, or whether stick with the static calculation. So I think very relevant question. Thank you for that.
Can I add something? Because I realize this is also an opportunity to kind of share this. I mean, what we see, and that's linked to both cascading use as well as in general biogenic material use. Those of you familiar with LCA will know that we now have in the latest EN standards, we have 4 GWP indicators. We have the GWP total, and then we have sub-indicators for GWP bio and fossil and land use change. And there is a tendency to just use the total one, which is summing up all the other 3. And we strongly advise against that. We think it's really crucial that we report all 3 or 4 indicators individually, because there are trade-off effects, especially between GWP fossil and GWP bio, that you would totally miss if you just sum it up to the total. And I think for properly understanding where the emissions are happening, also which direction emissions are going, if it's actually an emission or if it's a sink, it's quite crucial to keep them separate and report them transparently and separately. And also for the cascading use, we actually advocate for the use of a carbon content factor more than the GWP bio indicator, or in addition to that, to really become transparent about the carbon content of the materials. Because also with the GWP bio indicator, you might have both emissions and or uptake related to biogenic materials, and it's kind of a lack of transparency also there that will make it difficult to really make the best use of biogenic materials in the future.
Thank you so much. Very interesting. High level of granularity of the GWP is always interesting to better understand indeed the results and to interpret the results. Now we have four questions ahead of us, so I would like you to answer all of them. So if you can give quick answer, that would be great. So now a question to both of you, Zohaib and Martin. How could innovative LCA software startups collaborate with the GDBI initiative, particularly to help scale adoption and reduction in both the global north and the global south? Did you already imagine any synergies with GDBI and software startups?
Yes, absolutely. So GDBI is also a platform working with different tool developers, working with different actors out there. So we also speak with LCA software developers, LCA software startups. I think the most immediate way to support the work or kind of collaborate with GDBI is to first get in touch, obviously, but then consider using the shared standards that we are developing together with the partners. There is the open billing data format in its first version that is already out there, that is also built on not just our own work, but on as a synthesis of many people's work. So it's an alignment on the attributes that we consider relevant. It's also a suggestion on the structure of how to exchange LCA results. And it's also important to understand, we will look into a future revision of this open billing data format. So if that is something that you want to be involved in, then please get in touch. We have some very interesting learnings also from this first iteration. We now better understand which attributes we want to have as kind of required and which attributes we would consider optional. Also in terms of data structure and data formats, we have some interesting learnings. Actually, at this point, we might consider alternatives to JSON, because we see from the file compression perspective, the files are way too big in JSON, so we might move to things like Parquet, which gives us like a factor of 20 smaller files, especially if we have these detailed inventories that we're advocating for. So yes, just get in touch. There are opportunities to collaborate, and you can certainly integrate those exchange formats as part of your software, enable export in those formats, because that really helps. That really helps the exchange and the transparency and comparability globally.
Thank you so much. Another question for you, Zohaib, from Ireland. So here in Ireland, we will have soon a set of national generic embedded carbon data on different materials for use when no EPD is available. Interesting question. Now, is it possible to integrate generic embedded carbon factors into IFC data so BIM could produce A13 figures in real time? So how can we integrate embedded carbon factors into IFC data and BIM models? Do you think it's working right now? Is there any potential of acceleration there?
Thank you for that question. I think this is a very common practice, and if I'm aware, some time ago I read an article where the discussion is around using these generic embodied carbon factors and integrating them into IFC data where they don't have EPDs available. So I think it's a very, very common industry practice at the moment. Maybe not many people are aware of, because different countries are trying to work with the lack of data. So it's, I think, definitely recommended. You can go ahead with this approach, because in my knowledge, I guess this is something that is going on. And as soon as you have real EPDs to use data for, then switch from that data to that. So, and I would suggest also Martin to comment on this, because he has probably more background on BIM and LCA platforms.
Yes, I've done quite some work on BIM and LCA in the past. And I mean, in principle, you can add all sorts of information to your BIM model, right? So you can link numeric information to your materials also. And if you have a certain set of generic EPDs and the values from those that you want to work with and directly integrate it, you can just basically hard code that into your BIM model. I think that can be an interesting approach for certain types of modeling. I think the challenge is more related to the fact that in early design stages, you will not have modeled everything. So you need to have approaches that are not exclusively based on your material quantity. And we see that in the leading tools out there, that they also have approaches of kind of filling in the gaps in the early design stages to still offer a comprehensive assessment as much as possible with the limited data that you have in early design stages. But in principle, that's perfectly feasible. I think many tools are also really moving forward in linking your materials in the BIM model with more comprehensive EPD databases, so that you can really also choose lower carbon products and lower carbon materials as you progress in the design process.
Thank you. Now we have a question about potential collaboration between the Global South and GDBI. How can they contribute? Any key things that may easily be overlooked?
Yes, so actually it's a great time to ask this question. Just last week, I had the opportunity to speak with a very interesting delegation of African experts, material researchers, building researchers, and we're engaging now in a process of also developing a simple building LCA calculation tool, or whole life carbon calculation engine, I may say, which is not as detailed as the BIM-based approaches, but which should enable professionals and researchers in different world regions to kind of start doing a life cycle assessment of building structures, for example, in a very easy way. And for this, we're compiling an expert group. So if you're interested to contribute to this, to share your perspective on also the usability or what you want to see in such a tool, in such a software package, then please get in touch. We would be happy to hear from you.
Martin, I don't know if you know the answer, but it's a yes or no question. Does the levels require reporting GWP fossil?
I'm afraid I'm not on track with the latest developments of the levels.
I don't know neither.
Yeah, no.
Me neither.
So what I know from like the insights that I have on the EPPD kind of work is that there is this pragmatic choice of going for the GWP total on the main page, and then in subsequent pages maybe having also this sub indicators of fossil, bio, and so on. And yeah, wherever you come across it, please advocate for the disaggregated reporting of the different GWP indicators. It's really quite crucial. And Suhaib.
Thank you so much. We still have some questions, and thank you so much for your participation, but unfortunately we have only 2 minutes to go. So I'm going to close the session now. And first, I would like to thank both of you, Martin and Suhaib, for your very interesting presentation. I guess you can be in touch with anyone with your LinkedIn profiles or any of your websites where you have your contact details. Feel free to go back on the recording that once it will be shared, because we're going to post the videos on the buildinglocalbot.com website. So if you would like to see the replay, if you would like to share it, you will be notified soon once we will post it online. Also, if you are interested to jump in the next webinar, just say hi in the chat now. We will be happy to call you back once it will be planned. And next energy webinar might be about the reuse of metal structures and the environmental benefits and life cycle assessments. Thank you so much again, both of you, for this very interesting webinar. And I wish you a nice day and see you soon. Bye-bye.
Thank you very much.
Thank you. Bye-bye.
Bye.